There are a couple other varieties of limit problems that tend to present themselves, and so I'm going to make sure and work through a few of those examples. They're going to come in handy when we start to do our limit work later on, when we transition from limits to a concept called derivatives. And so this is the first variety. On the surface, it's very similar to what we've talked about so far. Always the first thing you try is direct substitution. Well, if you try direct substitution, you would get, direct substitution would produce, this is limit as x goes to 3. I have square root of x plus 1, so that's going to be the square root of 4, which we can say is 2 minus 2 over 3 minus 3. Yes, this does go to 0 over 0. So this is an indeterminate form, 0 divided by 0. And so remember, our rule is do some algebra or trigonometry later on. Do some algebra or trigonometry, simplify, and then try again. Well, this doesn't particularly lend itself to factoring of the kind we've done so far, so that's not really what is on offer here. What I'm going to do is, first off, I'm going to put, anytime we have binomials, it's a good idea to put those in parentheses to emphasize these binomials come as a single entity. And if there are radicals present, then very often the key is the algebra that you do is you multiply both the numerator and the denominator by the conjugate of this numerator. Or if this is in the denominator, multiply by the conjugate. Multiply by the conjugate of this radical expression. Remember, the conjugate of A minus B is A plus B. You change this sign. A common mistake students make is they want to change this sign. That's not correct. It's A minus B, and so the conjugate here is A plus B. And remember, this limit is equal to this limit. And so I'm going to multiply this numerator by the conjugate. But remember, if you multiply the numerator by that value, you must also multiply the denominator by that exact same value. So you multiply the numerator and the denominator by the conjugate of this radical expression. And when you multiply this out and do the limit again, this should give us a result. And I believe in this case it does. And so the key is this, in terms of the technique. So now from here on out, this is technique. Remember that when you multiply conjugates, you multiply first times first, last times last. But remember, when you do the O and the I from FOIL, because they're conjugates, they cancel out. So what you end up with is the first term squared minus the second term squared. Now, the non-conjugate factors down here, this is not the conjugate. The technique here is don't multiply this portion. The denominator in this case, just leave it alone. You'll see why here in just a minute. So don't multiply this portion out, but you do multiply the conjugates. When you multiply the conjugates, it's the first squared minus the last squared. Well, the square of the square root is x plus 1. It's the first term squared minus the last term squared. First term squared is x plus 1. Last term squared is 4. And now, I'm going to put this in parentheses as well. The rest of this is 100% technique. And so this becomes, look what we get. We get x minus 3, which is why I did two things. Number one is why I left this in parenthesis to emphasize this entire group cancels with entire group. And it's why you do not multiply this piece out. We are anticipating what's going to happen with these conjugates. So cancel here, or some people would say reduce. So cancel here. Remember, when you cancel everything from the numerator, you must leave behind a 1. And so This is equal to the limit. Remember, this limit is equal to this limit, which is equal to this limit. You continue to write limit as x approaches 3 until you actually do the substitution. So the simplified version here is limit x approaches 3. The denominator is, what's left over in the denominator is just this piece, this conjugate we had from earlier. What's left over in the numerator is just 1. And now, remember, our rule is do some algebra, simplify, try again. Now, because that numerator is 1, no matter what else happens, we're not going to get 0 divided by 0 because we know going in the numerator is equal to 1. So now we may stop writing the LIM, the limit expression, because now the numerator, and when we substitute x equals 3 is 1, substitute here, that's the square root of 3 plus 1 plus 2. I'll be explicit here. This is the square root of, this is 2 and 2. So that's 1/4. So that's another technique. When you have conjugates, the technique is you multiply the numerator and the denominator by the conjugate of that radical expression. When you have a radical expression, conjugate of the radical expression. Don't multiply these non-conjugates, just leave them alone. Multiply the conjugates is first one squared, always minus, first one squared minus last one squared is first one squared minus last one squared, and then simplify that result, substitute again, and you should be good to go.